All right, so today we're going to look at writing and graphing inequalities. Now for this, we need to know that this is less than, okay, this is greater than, this is less than or equal to, and this is greater than or equal to. And a way to remember that is less than looks like the Lexus symbol, right? And greater than looks like the stem of a capital G. And the line underneath is just or equal to. Okay, so we'll review that in class, but let's look at this one. It says write the sentences as an inequality. So you'll have word problems where you'll have to use these. So twice a number minus 7.11 is at most 2.1. Okay, so let's read it one at a time. Let me get my trusted blocker or whatever this is called. Okay, so we're going to block out that stuff. So it says twice a number. So twice anything is going to be 2 times. So 2 times what? A number. Do we know what that number is? No. And when you don't know a number, variable. So we're going to let it be n. I don't know, x. Choose a variable. Choose a letter. K. P. Whatever. Okay, on to the next. Minus. Oh, that's easy enough. Minus 7.11. And 7.11 is. Okay, usually is means equals. All right, but here we have is at most. Okay, so is at most. At most means the biggest it can get. Okay. So it's either going to be smaller than or equal to this number because that's the most it can be. Okay, so is at most 2.1. 2.1, and guess what? That's it. Okay, so there are different words here that you'll see. It'll be in the book, and we'll talk about it in class. But there are different words that will describe less than, greater than, less than, equal to, or greater than equal to. Okay, so let's look at the next one. Negative 5. Oh, negative 5 is more than the quotient of a number and 2. Let's block off the rest and do it one at a time. Negative 5. Just right. Negative 5. Focus. There we go. Negative 5 is usually equals, but is more than. So more than, another way of saying that is greater than. Okay, is more than the quotient. Now the quotient, you're going to see different words like sum, difference, product, quotient. So the sum of two numbers is the answer to addition, so you're basically adding them. Difference is the answer to subtraction, so you're subtracting those two numbers. Product is the answer to multiplication of those two numbers, and quotient is the answer to division. So the quotient means division. So the quotient, so we can put the division sign, but let's be fancy and put let's put a fraction bar. All right. So fraction bar, quotient of a number again. Let's put any number. Let's choose R this time. A number and 2. 2. Okay, that's it. Oh, let me clean this one up, the one in the front. 2n minus 7.11 is less than or equal to 2.1. Okay. Let's go on to the next. Tell whether the value is a solution of the inequality. So for these, whenever you need to, just like for equations, if you need to tell whether something is a solution, you have to plug it in. Substitute that number into the equation, or in this case, an inequality. So our inequality is negative x divided by 4 plus 13 is less than or equal to 7. And then this semicolon is just separating the value. Okay, so we're going to substitute 8 in for x. Let's do it. So we have negative 8 divided by 4 plus 13 is less than or equal to 7. And I should have left more space. So negative 8 divided by 4 is 2. Negative 2 plus 13 is less than or equal to 7. I'll bring that over here, sorry. And negative 2 plus 13 is 11. Is less than or equal to 7. Is 11 less than or equal to 7? No. So 8 is not a solution. Not a solution. Not true. Okay. On to the next. So we have 5 is greater than, what is this? Oh, 14 divided by 7 times v plus 7v. And v is equal to 2. Let's see if it works. So just like before, we're going to substitute 2. And for the v's, here we have 2 v's. Okay, so let's plug it in. 15 is greater than 14 divided by 7 times 2. Remember, if you're substituting when the variable is right next to that number, put parentheses because that's multiplication. So 7 times the number again. All right. So we get 15 is greater than 14 divided by 14. Hey, that's 1. Plus 14. Ooh, I like where this is heading. So you get 14 divided by 14 is 1 plus 14. And we get 15 is greater than 15. Is that true? No. 15 is not greater than 15. It's equal to. So this is also not true. So no solution. Oh, sorry, not a solution. Not bad. Okay. Let's look at the next one. 25 plus r is greater than or equal to negative 11r plus 11, and r is equal to negative 3. Let's try. So 25 plus negative 3 is greater than or equal to, and I'm putting parentheses around the negative 3 because there's a plus sign. I don't want it to get confused. So it's eventually going to become negative, or minus 3. Okay. And negative 11 times negative 3 plus 11. Oops, why did I put that? So 25 minus 3 is greater than or equal to negative 11 times negative 3 is positive 33. And, oh, this isn't what I, okay. So we get plus 11, and we get 25 minus 3 is 22. And here we get 44. Is 22 greater than or equal to 44? No. Okay, but this isn't what I intended. I'm sorry. I should have put minus 11 here. Okay, so let me do it really quickly. So if you had 25 plus r, so this is not a solution. 25 plus r is greater than or equal to negative 11r minus 11 is what I wanted. Sorry. I have 25 plus negative 3 is greater than or equal to negative 11 times negative 3 minus 11. And then we get 25 minus 3 is greater than or equal to 33 minus 11. So we get 22 is greater than or equal to 22. This looks similar to this problem over here, number 4, right? But here, this time we have an equal sign. Is 22 greater than 22? No, but is 22 equal to 22? Yes, it is. So, yes, so it's a solution. Yay, finally. All right, now let's graph the inequalities. So this is how we graph. I have one of each, so greater than, and you'll see the rest. Okay, so we'll have greater than, less than or equal to, and greater than or equal to. So don't worry, you'll get to see them all. So x is greater than -3. Okay. You want the variable should be on the left side. Okay. Does it need to be? No. But is it going to make life easier? If it is, yeah. Okay. So here, x is on the left side. Yay. So we just make our number line. You don't really need too many numbers. Yeah, let's put, you could do whatever. I usually put the -3 in the middle. -4, -5, and bigger is -2, -1. So since it's greater than, we need a circle at that -3, right? And the marking above it. And it's not shaded because there's no or equal to, okay? Greater than or less than is going to be just an open circle, just like that. And now we like to have the variable on the left side because we could just follow that inequality. Doesn't that look like an arrow going to the left? I mean to the right? It does. So that's the way it's shaded. Okay, this is saying any number greater than -3. So what's greater than -3? -2, -1, 0, 1, 2, 3, 4, 5, 6, all those numbers. But also including all the numbers in between, like -2.99, -2.5, -1.7. Okay, so that's that. And here, spaghetti-o. So the variable is not on the left side, so we switch it. So we put the variable on the left, the number on the right, but whenever we switch it, we also have to switch that inequality. So instead of being greater than, it's less than. Hey, okay, so you have 3 is less than -3. All right, so the variable is by itself, and it's on the left side. And -3, -4, -5, -2. Again, no or equal to, so it's an open circle. And which way, since our variable is on the left, we can look at that. Which way the inequality is pointing. It's pointing to the left. So we're going to shade to the left. So this is saying all the numbers less than -3. So it includes -4, -5, -5.7. Okay, whatever. Number 8. X is less than or equal to -3. So we're going to put our number line. Oh, the variable is on the left side. Yay. You don't have to switch anything. Let's put another one just for fun. -3, -4, -5, -2, -1. All right. So here we're going to circle -3, and because of that or equal to, we're going to shade it in. Okay, it's going to be a closed circle. And which way is the inequality pointing? To the left. That one's the same. Ta-da! So same thing as number 7, except this is a closed circle. 7 was an open circle. And last one, number 9. Okay, it's not on the left, it's on the right side, so switch it. X goes on the left, -3 goes on the right. But you also have to switch the inequality so that less than or equal to becomes greater than or equal to. So -3, -4, -5, -2, -1, and it's It has the or equal to, so we're going to shade it in. It's going to be a closed circle. And which way is that inequality pointing? To the right. And that's it.